Dr. Babasaheb Ambedkar Open University.
Namaskar, dear students and learner of this course. I, Professor Kamesh Rawal, I welcomes you in the video lecture series of Dr. Babasaheb Ambedkar Open University. Fine, so today we will discuss your unit number 2, that is nothing but it's a computer organization and data processing. Fine. So here basically what we need to learn is, right, so see in the previous session we have discussed so many things, right, how the computer is actually invented, what was the motive to invent that computer. Later on we have seen we can carried out a lot of different activities by using this computer in which there is no computation is involved, right. We can send a mail, we can do the chatting, you know, there are a lot of things are there, we can watch the movie, right, we can listen the music, and there are so many things are there in which, you know, there is no computation is involved, right. So basically how we can define our today's computer. Fine. So we have seen that the computer, it's actually taking unstructured raw material and unstructured facts. These are the nothing, it is called a data. So data that we are inputting into the computer system, our system will act as a data processor, right. So it will process the data, and finally after processing a data, the computer will provide information which actually we want from the computer system. Okay. So and that way, right, here we are discussing a computer organization. Fine. So here what we will discuss? We will discuss the various components, right, which is actually used in the computer. So as we see, let's suppose if we have the computer, then some of the parts that you are already knowing, right. For example, that we have the keyboard, by using the keyboard we can type the data. We have the mouse, right, so it's a pointing device. We have a monitor, we can have a printer, you know, speaker, and a lot of things. And along with that, we have discussed in the last session that what we have is we have a cabinet, and inside the cabinet there are so many components are there. So why we are using this different type of components with the computer system? What are the roles which will be played by all these different type of hardware? So we will discuss on this thing, right. Second thing, we will also discuss the advantages and disadvantages, right, and finally we will discuss on the programming languages, right. So different type of programming languages are there. What is actually the programming language and why should we need to learn these languages? Fine. So we are just coming to this all points. Fine. Now here you can see this is the block diagram of the computer, right. So first of all, let's suppose if we'll talk about this part, this is called a data. Data means what? It is a unstructured raw material and unstructured facts, right, which will be inputted, which will be entered by the user. And obviously how the user can input all these things? So obviously here some input devices are there, right. So user can feed the data, user can input the data by using certain devices like keyboard is there, mouse is there, and there are so many other input devices are there, right. So input devices, they will take the data and it will submit that data to the data processor, right. So here what we have is this dotted line. The bigger box is nothing, it is your you know, system, it is your computer system. Okay. Now here, you know, what we have is we have mainly two components are there in our computer system, right. The first component is what? It is called a storage unit, right. So storage unit, or sometimes also you can consider this as a memory unit, right. So here basically storage unit of the computer is actually made from a different type of memories, right. How many type of memories are there in the storage unit? So mainly there are two type of memories are there. The first memory is called a primary memory, okay, and then the second memory, it is a secondary memory. Now what is actually a primary memory? What is secondary memory? So we are just coming to this point. We will discuss it in a very great detailed manner. Fine. But the thing is, here two type of memories are there: primary memory as well as the secondary memory, right? So this is what it is providing a storage. Fine. Let's suppose if the user has entered the data, for example. So where we need to store the data? So obviously we need to store the data in some memory, right? And for that purpose, we are using this memories called primary memory and secondary memory. Then what is this? This is called a CPU. It is called a central processing unit, right? This solid line box is actually indicating what? It is a central processing unit. Now this central processing unit is actually responsible to process the data, right? But where is the data which is inputted by the user? Obviously it is there in the storage unit, right? So now the CPU will fetch the data from the storage unit, it will process it, and finally whatever information will be obtained by the CPU, it will be placed in the memory unit itself, right? So again, here the memory unit is most important. Whatever raw material, whatever data is given by the user, by using the input devices, we are just loading that data into the memory unit, right? That is called a storage unit. We are putting all the data into the storage. Then from the storage, the CPU will take the data, it will process the data, and finally it will generate the output, right? So that output again it will put where? Again into the storage unit, again into the memories. Fine. Sometimes what happen? Some intermediate result will be produced, right? So when the CPU is doing a processing work, at that time some intermediate results will be generated, and that has to be stored, right? So again here the storage unit will be used. Whatever intermediate results are produced, not final output, but the intermediate results are produced, again they will be loaded into the storage unit. So here there are two type of storage units are there: secondary memory and primary memory, and basically this memory provides a storage, right? So here data will be stored, information will be stored, and finally intermediate results will be stored. Okay. Now here there are two type of, the CPU can be divided into two parts. One is a control unit, right? Basically the role of the control unit is to control the various equipment and circuitries which are actually associated with the computer system. So basically in the computer system, whatever circuitries are there or whatever components are there, like mouse, keyboard, monitor, etc., all the devices whatever we are associating or attaching with the computer, that all devices will be controlled by this control unit, right? And what is control unit? It is nothing, it is a part of your CPU, central processing unit. Fine. Now I think you people are already doing a programming work, right? You are learning a C programming. So we know that the C is what? It is a language, it is a programming language, and by mean of the programming language you are providing a lot of instruction to the computer, right? So here whatever instructions you are writing in any programming language, later on we will see the different type of programming language, like assembly language is there, C language is there, C++ language is there. So basically in any language, whenever you are writing the program or you are executing the program, your instructions, your each and every instructions will be executed in this particular unit. It's known as arithmetic and logical unit. So here this part of the central processing unit called ALU, or arithmetic and logical unit, that has so many different type of circuitries. Fine. And let's suppose if you are writing this type of instruction, for example, let's suppose if I have written something like this, let my instruction is something 2 plus 3. Right. So let's suppose if I have returned this instruction, so here the computer needs to add this 2 number, okay, and here there will be a separate circuitry is there which is called adder, right? Adder is the circuitry which takes 2 input, 2 and 3, and it will produce 5. Okay, so here adder is a one circuit, right, and that has to be used because here you have used this operator called a plus, right? So there are so many. For addition purpose you have the adder, for subtracting purpose some another circuitry will be used, right? For multiplying purpose another circuitry will be used, right? So for each and every instruction, whatever you are providing to the computer system, what we have is we have a separate circuitries for each instruction, okay, and this instructions are located under a unit called arithmetic and logical unit, right? So which is actually responsible to perform any kind of arithmetic arithmetic operation or logical operation. Sometimes we are writing if condition, we are running a loop, so these are all, we can say it's a logical instructions, right? So here ALU, arithmetic and logical unit, is there, which is responsible to execute each and every instruction. Fine. So with the help of control unit and with the help of arithmetic and logical unit, what we have done is we have processed the data. Now from where we are taking the data? So obviously the data is entered by the user using input devices, but that we have stored in the storage unit, right? So we are just fetching the data from the storage unit, we are just processing it. Again we are putting the information or process the data into the storage unit. Finally what happened? The output devices, there are several output devices are there. For example, user can see the output by using a monitor, right? Or similarly user can also take a printout of it. So here basically the user will use any output device like a printer or monitor, etc., etc. So this printer, monitor, this all different type of devices are what? They are output devices, right? And output devices will produce output, and that is nothing, it is a information, it is a processed data, and that we are giving to the user, right? So here there are two type of lines I have used. This type of solid line, it is actually showing a flow of data, and this dotted line is there, which is actually indicating it is a controlling signal, right? So basically as I said, control unit is controlling all the circuitries of the computer. So here every circuitry, input devices, output devices, all the devices, circuitries which is placed in the ALU, that everything is controlled by the control unit, right? Okay, fine. So now we will just go ahead and we will read what is actually input devices, what is output devices. Fine. So input devices, already we have discussed, input devices are used to input the data, right? Sometimes we are also executing the commands or instructions, right? So to input the data or to input the command, right, what we are doing is we are using input devices. What type of input devices are there? So using keyboard is one of the input device, we can type the data. Mouse is again input device. Why it is called an input device? Because we can give a command, right? How you are shutting down your system? You are just clicking on a start menu, so you are just giving a command using your mouse. So whatever command you are giving through the mouse, it will be captured as an input to the system, right? So keyboard, mouse, mic, cameras, these are all different type of input devices, right? We will see the different type of input devices, what are their architectures are there in a greater detail. There is one dedicated chapter is there. Okay, now we'll talk about a system. So as we have seen, let's suppose if we'll talk about a system, then the system will have a mainly two component, right? The first component is what? It is called a storage unit, and the second component is a CPU or central processing unit, right? What is the job of the system? What is the role of the computer system? It takes the data from the user using input devices. It will process the data by using storage devices, storage unit and central processing unit, and then after processing the data, what will be produced? It produce information. That information we are providing to the user by using some output devices, right? So here output devices will be there. Okay, fine. Okay, now we'll talk about a storage unit. So see, there are two type of storage units are there, right? Storage unit which consist of different type of memories. So mainly we are using two type of memories in the computer system. system needs a memory to store the data and information as well as some intermediate results too, right? Storage unit mainly divided into two components. One is called a primary memory and second is a secondary memory, right? So we will just see what is actually primary memory, why should we need to use it, and what is secondary memory, right? What is the importance of the secondary memory? Fine. So here, I have shown the photograph of the random access memory. So here what you have is you have this type of memory, right? This is called your primary memory. It is also known as a random access memory, right? So in fact, in the primary memory, there are mainly two type of memories are there: random access memory RAM and read only memory, that is called ROM, right? So RAM and ROM both are primary storage. Now see what are the primary storage. So here basically the primary storage are made from electronic circuits. Here you can see the black portion. This is the first black portion is there, right? And this is the second black portion, right? So this black portion, whatever is there on this small board, it is known as a IC. They are integrated circuits, right? So this type of memory which is actually made from IC or integrated circuits, right? That type of memory which is we are making from the electronic circuits or ICs, it is usually your primary memory, right? So primary memory are actually constructed by using electronic circuits, and because because we are here storing the data by using electronic circuits, so obviously this memory will be a faster memory, right? So this is the faster memory. Okay, so here computer has a memory storage called a random access memory or RAM. Computer stores data to be processed, intermediate results and information in the RAM. So basically when the CPU is taking the data, obviously it will fetch the data from the random access memory. Sometimes suppose CPU is producing intermediate result, again it will be placed into the random access memory, right? And similarly, suppose if some output is generated, right, some data will be processed and information is produced, that information again CPU will put where? Into the random access memory. So basically CPU uses random access memory very frequently, right? Why? Because the CPU is a very fast device and it needs a fast memory. So here the random access memory is a faster memory, and because of that CPU frequently uses a random access memory, right? Now one question will arise in your mind that, sir, suppose if the random access memory is a faster memory, then why should we need to use a secondary memory? The thing is, RAM is a volatile memory, right? Now what is volatile? Volatile means it is relevant with the power supply, right? Suppose if you are giving a power supply to the computer system, whatever data you have, you can put it into the random access memory, right? But if you switch off the machine, if you shut down the machine, in that case, or if you discontinue the power supply, whatever content is there within the RAM, that everything will be erased, right? So RAM cannot store the data permanently, right? Yeah, it is true that RAM is a faster memory and CPU always works with the random access memory, but the problem with the random access memory is it is a volatile memory. It needs a consistent power supply. If you discontinue the power supply, right, in that case whatever data is there in the random access memory, everything will be erased and you will get a blank RAM. Okay, so that is what the major problem with the random access memory. Okay, random access memory is always faster than the secondary memory. Usually, random access memories are available in the GBs. You will get a 2 GB of RAM, 4 GB, 16 GB of RAM. It is easily available in a today's market. It is costly memory than the secondary memory, right? So this memory is obviously it is a faster memory made from the circuitry, and because of that this memory is considered as a costly memory, right? Fine. Now the second thing is called a secondary memory. So if anybody is asking you, let's suppose if you have a random access memory, if you have a primary memory, then why should we need to use a secondary memory? we are using secondary memory as a permanent storage, right? Because the random access memory or RAM cannot store the data permanently. We are using a secondary memory. Usually when we are using the system at that time, this type of device we are attaching in the cabinet, and this device is nothing, it is called a hard disk drive. In fact, there are so many different type of memories are there which we are considering as a secondary memory, but in a system obviously this particular drive will be there, which is called hard disk drive or HDD, right? It is nothing, it is called a secondary memory. Secondary memory provides a permanent storage, right? So once if you have typed the later, whatever characters you have typed, that will be there in the random access memory, right? And what we are doing after typing the later, we are saving that document, right? So whenever you are clicking on a save button, whatever data is there in the random access memory, it will be stored into the hard drive, which is called a secondary memory. And as you know, once the data is saved, it will be transferred into the secondary memory, then it will remain as it is, it will remain permanent even though you discontinue a power supply. Fine. So here the secondary memory can store the data permanently, and because of that we are using a secondary memory, right? It is slow compared to the speed of the CPU. Okay, if the hard disk can store the data permanently, then again one question will arise in your mind, sir, why should we are using primary memory then, right? Why we are not using only the secondary memory? The problem with the secondary memory, it is a slow memory, and our fast CPU is always fast, it is a tremendous fast, it is 1,000 times faster than the random access memory. The CPU is 1,000 times faster than the random access memory, and let's suppose if we'll talk about this is your random access memory, and this is a hard disk is again 1,000 times slower than the random access memory. So CPU don't want to interact with the hard disk directly, right? CPU is not interacting with the hard disk directly. So to overcome this problem of a speed mismatch, we have inserted a faster memory between these two. Now see, here we have inserted a RAM. Okay, so what happened, this hard disk is a slower, so from that device we are just storing the data into a random access memory. Because RAM is 1,000 times faster than this hard disk, now the CPU can take the data from the random access memory and it will start processing. Okay, but CPU never interact with the hard disk directly, right? So because why CPU is not interacting with the hard disk directly? Because the speed of the hard disk is much more slower. So usually all the secondary memories are slower, right? It is available in a larger size, right? Let's suppose if you want to buy a hard disk, then easily the hard disks are available in the terabytes, right? So hard disk are available in the size of terabyte, 1 TB, 2 TB of hard disk you can easily get it from the market. Okay, hard disks are generally used that is as a secondary memory into the computer system. Apart from the hard disk, there are so many other things are there. We are using a pen drive, we are using a floppy disk, CD-ROMs, memory cards, DVDs. All these things are actually an example of what? Secondary memory. Okay, secondary memories are always cheaper than the primary memory, right? So this memory is quite cheaper than the your random access memory or primary memory. Okay, fine. Now we'll talk about a central processing unit. So as I said, right, inside the cabinet what we have is we have a motherboard, and on the motherboard we are inserting one small IC, and this size of small IC is known as your CPU. Here what I have done is I have placed a photograph of the CPU, right? So this is what a CPU. This is a small IC, it's an integrated circuit, and it works in the speed of nanosecond, right? 10⁹ part of the second. Okay. Now this small chip, this small processor, right, central processing unit is divided into 3 main parts. One is called memory unit, another is called a control unit, and one more is called arithmetic and logical unit, right? So the CPU is divided into three parts: memory unit, control unit, and arithmetic and logical unit. As we have discussed, CPU itself will have one small memory inserted into the chip of the CPU. It is called registers, right? So CPU has a two type of memory. One is called registers and another one is called cache memory. Register, it is the fastest memory in the world, right, which is actually made from a flip-flop, right? This memory is a more costly memory, right, or you can say it's a costliest memory, which is available in a very small size. It is available in the bytes, okay? So this register, which is placed in the chip of the CPU, is called a memory unit. Okay, as we have discussed, what is the role of a control unit? It controls various devices and circuitries. And another thing that is called ALU. ALU stands for arithmetic and logical unit, which is responsible to execute each and every instruction. But which circuitry has to be used to execute a specific instruction? Obviously, that decision will be taken by a control unit, right? So whenever the instruction is coming, control unit will see, yes, here addition has to be done. So control unit will send a signal to the adder. Adder will be activated, and then control unit will pass the data. So adder will produce a addition of that two numbers, right? So you know, ALU will have a lot of circuitries, but at what time which circuitry has to be run or execute, that decision will be taken by the control unit. One more, that is called output devices. So as we have discussed, printer, speaker, monitor, these all are output devices. Whatever information will be produced by our system, that will be given to the user by using output devices. Fine. So mainly, you know, today we have focused on a block diagram, and we have seen various components: input devices, output devices, storage unit, as well as a CPU, right? We'll meet in the next session and we will discuss few more things, right? What are the advantages are there, what are the disadvantages are there, some characteristics of the computer, and lot of things. Fine. So we'll meet in the next session. Till then, take care and bye bye.